Hello friends, today we are going to discuss about HDFS. So HDFS is a Hadoop distributed file system, and in HDFS data is distributed across several systems. So we have parallel system in our cluster, in our server. So in all the system data is replicated, and there should be uh, data loss. So if data is lost in the one system, we can get the data in the other system. So that is the replication of the data to prevent the failure of the machines. Okay, so it is a way to store the data or to process the data in a fashion where data is distributed across different server or system. So that's what we tell as Hadoop distributed file system. Okay, it's a file system and that is distributed across several systems. So use of HDFS, like whenever we are going to use for large files, if files are of huge size, then we can use HDFS. It's not recommended to use the smaller size of files for HDFS. Streaming data access. So there is two types of data as we already know. One is historical or batch data. So if historical data is there, then we can easily load or process the data. But when it comes for streaming data access, sorry, HDFS is well known for its streaming data access or processing. So it once write and read many times. We can write the data at once, and we can read as much as we want from the HDFS. And commodity hardware, it works on low cost hardware. So basically that hardware that uses for storing the data, it is for it is on the side of low cost. So it saves our money, as well as we can introduce more of the hardware on the cheaper side instead of using the higher cost hardware at a once. Okay, low latency data access, where not to use. So where to use, as I said, like for very large, for streaming and commodity hardware. Okay, now where not to use is low latency data access. So the application which requires the more time to access the first data should not be used. Let's say there is an application, and if we are going to read the data from one by one, and if one first data itself there is more time to access for the first data, then that cannot be suitable for the HDFS file system. So it gives importance to the whole data rather than first entry of data. So let's say there are data A, B, C, D, E, and we are going to read the data A first. So first data itself takes too much time, then it is the waste of time as well as memory. So it's better to read whole data at a time. A, B, C, D, E, whole data. Okay, lots of small files. So for small files, we recommend HDFS is not a better practice to use, because metadata of files are stored in memory of name node. So we will introduce name node and data node, all are in HDFS architecture. So as of now, we have to just understand. So metadata is nothing, the information about the data which resides in the memory of name node. Okay, so there will be two type of node in the cluster. I will explain you later. As of now, just understand name node. Okay, so in name node, if files are small, it will take a lot of memory, so memory will be wasted, because there is a fixed memory for data in the name node. So if let's say size is 2 MB and block size is 128 MB, so small files we are using, it takes a lot of block, so it will be wasted of the memory. So as for a good practitioner of the big data scientist, for lot of small files, I mean for small files, HDFS is not a good practice. Okay. And multiple writes, if we, it provides facility to write once, read many times. Okay, so if we want to write many times, then HDFS is not a good practice. But if we write once and read many times, then it is good practice to use HDFS, because it gives us facility to read as much as possible, but you have to write the data only once. Okay, any doubt guys, please comment below, and you can ask any questions related to big data. So now we will go to the next point. So guys, these are the very uh, you know important concepts as per the interview, as per the placement, and as for IT related interviews. So basically what I try to explain here is, there are some basics concepts of HDFS, like there is blocks, name node, data node, as I earlier says. So minimum amount of data that it can read or write is, that is a block. Okay, so data resides in a block. Let's say you got some 60 MB of data, so it will reside in the first block 128 MB, and the rest of the memory will be useless. So that's why we said, for a small file, HDFS is not a good practice. Okay, so by default block size is 128 MB, 128 MB, like that data will be uh, so let's say if file size is 130 MB, so you will ask, sir, what will be the where it will store? So that's a good question. So if it is 130 MB, 128 MB will resides in the first block, and rest 2 MB will resides in the second block. Okay, so block concept is clear. Now we are going to discuss about the name node. So name node, you can say it's a master, it's a head, like headmaster of the school. So name node acts as a master node. It knows the status of files and information. Like you can say admin knows all the employee or all the students of data, and admin knows about what is the behavior of the data and what type of data, like it's a head office of the HDFS. Now it stores metadata of the files. As I said, it does not store the actual data, it just stores the metadata of the files. Let's say what is the file type, and what is the file permission. Okay, if it's read write, or both, or access permission, location where it resides, and size of each block. Okay, so basically name node is will be treated as a master node. Let's say there is a headmaster in the school, and he or she has all the facility to know about the students, which type of students, what is the address, what is the phone number, who is the guardian, and what is the permission to that. Okay, when it got admission, when it got left that school or college. So same type name node will be. So here files are students, and name node will be treated as admin or headmaster. So open, close, and rename of file is done by name node only. Okay, so if you want to open the file, you have to consult to name node. If you want to close the file, you have to go to the name node. If you want to rename of file, then name node will be treated as to rename the file. Now come to data node. It works on the slave system. Okay, so as I said, master and slave architecture. So master will be name node and slave will be data node. So actual data stores in the data node instructed by name node. Okay. So whatever data uh, is there, that will be stored in the data node. But who will instruct? Name node will instruct. And it should possesses high memory to store more data. Okay. So if you want to store more data, then it possesses high memory. So it requires high memory to store the data. Let's say if you want to store the data, then you should require more memory, right? Are you getting me? If any doubt, please comment in the comment section. And if you want to have just information of data, then you can have small size of memory. So that's what name node possesses less memory and data node possesses higher memory to comparison with name node because it stores more data. Okay. So guys, thank you for this classes, and I will continue to teach you HDFS architecture. Then we will slowly go for the HDFS commands and setup of HDFS cluster. So as of now, I have made 4 videos on big data Hadoop. First one is Hadoop concept. Second one is types of views, what type of data it is. Then types of data, I mean data type. Types of data and data type, that is different. Types of data is like semi-structured, unstructured, and data type is different. So guys, comment me the topics related to HDFS or big data. I will definitely add into that. And later on, I will provide some interview related questions. So hope you like the video. Please subscribe the channel Satya Learning Center, and you can post questions on the comment section, and please put your questions in an elegant way so that I can answer it carefully. So thanks guys, and you can see like HDFS and use of HDFS, where not to use HDFS concept. So these 4 slides will be very helpful for you in the coming interview. So thanks guys.